Okay, today guys we are going to talk about ellipses, and that's basically the math word for oval. There's lots of stuff that you can learn about how they're made, and I can show you a way to draw them if you want me to. But for right now we're going to focus on the main parts of the ellipses and how we find those. On both of these ellipses I have a black line running through the middle. And this one is kind of more horizontal. This one's kind of more vertical. So ellipses can be turned different ways. That's my point there. But this black line is the longest line going through the middle, horizontally here, vertically here. It's called the major axis. So I'm going to write major axis. And that again is this black line. The red line is the axis that would go the other way from through the middle, and that one is called the minor axis because it's obviously the smaller of the two lines going through the middle there. So minor axis. And we have a couple of other things going on. Obviously right here and here is the center of the ellipse, and on the ends you have vertices, and some books that you'll find will talk about the major vertices and the minor vertices. Some just say vertices, and so this is a vertex, this is a vertex, this is a vertex, and this is a vertex. So it just depends on how formal your book wants to get with this. But if they just say vertices, first of all look and see if they're talking about the major ones, because those are the main ones that get used a lot. The other thing that we're missing here are focus points, and we did focus points with parabolas. Now we're going to do them with ellipses, and ellipses have two of them. And the focus points are somewhere between the center and the vertex. So I have a focus point here, maybe here, on this one, here, and here. And notice on the horizontal type ellipse, you have the major vertices, the major axis, the focus points are all horizontal. On the vertical one, the major axis, the focus points, the vertices, the center, they're all vertical alignment. Again, F is your focus point, and since we have two of those, the plural of that would be foci. If you see that word, that just means more than one. Okay, so now we're going to talk about the standard form of the equation of an ellipse, and it's going to look like this right here. If you'll look at just the top part, it should remind you of the equation of a circle. And on the bottom, we have this a squared and the b squared that we're going to talk about in a second. There's always a plus in the middle, and it should always be equal to 1. Okay, what do these numbers mean? Well, a, which we're finding a squared right here, is the distance from the center to the left or the right. And then b is the distance from the center up or down, and so b squared's right here. So that's where you locate those two things to find what a and b are. And basically you're going to, from your center, you're going to count left and right whatever a is, and count up and down whatever b is, and then you'll be able to draw your ellipse. Now c, it's not in your formula. C is the distance from the center to the focus points. And so we need to be able to locate those focus points, and C has its own way to be figured out. It's not something that you can look at the equation and say, oh, C is this. We have another way of finding. Okay, this is how I want you to remember how to find C. The equation that I want you to think of is C squared is big minus small. The big and the small are the a squared and the b squared from the formula. So you can just look at the two denominators, and whichever one's bigger, subtract the smaller one, and that's your c squared. You'll have to take the square root to actually get c, but to me this is the easiest way to remember it. Another thing that might come up is eccentricity. of the ellipse, and that's basically a big word that means a measure of the ovalness of it. And the way that you can answer a question about the eccentricity is using this little formula. E for eccentricity is C over the square root of the big number. And again, C is that distance from the center to your focus point, and the square root of the biggest number, whether that's a squared or b squared. That may depend on each problem. Okay, I'm going to do this example first. Sometimes you get them where they don't look like what I just showed you, and they're missing the fraction part and they're not equal to 1. This case is really simple. You can just divide everything by 36 and get something that looks like it should. Well, 4 over 36 will reduce to 1/9, so this will be x squared over 9. And then y squared over 36 doesn't reduce, so you have still the 36. And then 36 over 36 is 1. So here is my equation in the form that I'm looking for. Now, some of you are like, well, the parentheses not there. If the parentheses are not there, that means that h and k are 0. So with just a plain x squared and a plain y squared, I know that my center is at 0, 0. Then I look under my x squared to find my a. It is the square root of this number. So sometimes it's a pretty number, like in this case, the square root of 9 is 3. We know that. So a is 3. B is under y, and so b squared is 36, so b would be 6. You take the square roots of those numbers to get a and b. And then we move to c, and that's what I was talking about on a couple screens ago. C squared is the big minus the small. And so look at these two numbers. I'm going to do the big one minus the small one. So 36 minus 9, which is 27. And so C is going to be the square root of 27. But since we're trying to graph it, I'm going to go ahead and say that's about 5.19, because I need to kind of judge where that's going to be on a number line. Then if they ask about the eccentricity, I'm doing C, which is the 5.19 or square root of 27, over the square root of the big number. And in this case, the big one was 36. So that's about 0.865 if they ask for that. Now let's sketch. Okay, I'm going to locate all of these important things, obviously with the exception of the eccentricity. So our center is at 0, 0. Go ahead and mark that. Since a is 3, that means I'm going to go 3 in each direction on the x-axis. And I'm going to put a point. With b being 6, I'm going to go up 6 and down 6. And that gives me the points to connect the best I can to make an oval shape. Struggling a little bit there. These aren't the easiest things to draw, but we'll get the point. Alright, you also want to put in your focus points, and so that's why I wanted that 5.19 right here, because my focus points are going to be on my major axis, and in this case that's vertical, and I need to plot them. So 5.19, I'm going to say, is about right in here. You're just guessing, to be honest, but you want to, kind of get as close to that number as you can. So I would go down 5.19 to the best of my ability and put another one, they're disappearing on me, to show where the focus points are. So there's my focus points, there's my sketch. Okay, for our second example, I've already got it in the standard form. We're equal to 1. We have a plus. Everything looks the way it should. What's changed in this one is that the center, if you'll notice, I've got the parentheses back. So the x, because it doesn't have parentheses, means that that first part is 0. So our center is 0 something. And then here with the y, it's just like with a circle. You change the sign. So the center would be at 0, 1. Then you look under your x to find a, and so the square root of 16 would be 4. You look under the y's to find b, the square root of 25, is 5. And then your c squared is your big number minus your small number. So in this case, 25 minus 16, which is 9. And so to do c, you do the square root of that number, which would be 3. Then our eccentricity would be 3 over the square root of the big number, so 3 over the square root of 25, which would be 0.6. And again, you just need to do that if they ask for it. These others are what you need to actually graph. Now, if I want to come over and graph, I'm going to first start with my center at 0, 1. So 0, 1, here's my center. A is 4. You count that distance from your center. So we're not going to be on the x or y axis. We're going to be up above that now. So with A being 4, I'm from the center going to go right 4 and put a dot, and left 4 and put a dot. And then my B is 5, so I'm going to go up from the center 5, put a dot, and down 5. So 1, 2, 3, 4, 5. Then I can sketch my ellipse. Now, sometimes they're going to make you find those points. And so I figure if you can plot them, then you can figure out that this is the point for 1, or that this is the point 0, 6. Because sometimes they'll ask you for the vertices. The C is 3, so our focus points, you have to determine, is this horizontal or vertical? And since it's longer this way than it is this way, it's a vertical one. So our C being 3 means I'm going to count from the center up 3, put a focus point, and down 3, and put a focus point. So those are my focus points for this one. Okay, for our third example, I have one that the center doesn't have any zeros. It's already in the form that we need it. So let's locate the center first. And so when you look at the x's, you use the opposite sign. So -2, look at the y's, -1. So center is at -2, -1. Then the A, you're looking under the x, so we're looking at 49. Take the square root of that, you get 7. B, the square root of 36, is 6. And then c squared will be the big one minus the small one. And so in this case, that'll be 13. And we take the square root of that to get c, so that'll be 3.6. If you need to find the eccentricity, you put in the 3.6 and divide it by the square root of the big one, which is 49. And in this case, you get a 0.53 as your answer. Now, when we come over to sketch, I'm going to start with the center. So -2, -1, there's my center. Since A is 7, I'm going to be going left and right 7. So 1, 2, 3, 4, 5, 6, 7. Remember, it's from the center, so it's down at -1. And then the other way, down here. So I have these 2 points, left and right. Then my B is 6, so I'm going to go up and down 6. So 1, 2, 3, 4, 5, 6. And down 1, 2, 3, 4, 5, 6. And I've done a very bad job drawing my x and y axis, but the idea is still there. Connect your points, make your ellipse. And now, before you put in your focus points, you have to decide, is it a horizontal or a vertical? Since A is bigger than B, this one is horizontal. It's the first one we've done that's horizontal. So our focus points will be left and right. 3.6 from the center. So from the center, count 1, 2, 3, and a little bit. And then back 1, 2, 3, and a little bit. And there's your focus points.